Yes. So I'd just like to introduce you to Zaneeb. We haven't actually met. Hopefully we'll see each other tomorrow because I'm coming over to Wagga. And she's going to do a presentation on augmented and virtual realities. So thank you very much, and I'm going to hand it over to you now.
You're welcome. I will try to do my best to introduce these concepts. These concepts are really comprehensive and so many details in it. I try to clarify everything in a basic way. I hope everything will be good. May I?
We appreciate your time, so thank you. Yes, so start whenever you're ready.
All right, thank you very much. My name is Zeynep Taçkın. I will try to explain the mixed reality, augmented reality, and virtual reality concepts to you. And when we look at the Gartner's hype cycle today, mixed reality environments has a kind of decreasing, and this is the main reason of that decreasing process is actually the expensive equipments and also the integration of these equipments into our educational world. But augmented reality's increasing period is much more faster thanks to the providing mobile hand devices supports. So where these concepts came from, when we look at that, the Milgrams offered the reality continuum, and he create that diagram, not the whole this diagram, the part of that. The real environment could be think as a 0 point, and the virtual environment could be think as a 1 point. We can imagine this area as a slider. 1 and 0 points are the essential expectations of us, but the between all that area.
Zaneeb, sorry, can I just stop you just for a moment? Is there a Bridget running, or because you have
there
got a
is.
PowerPoint running?
Yeah, there is a Bridget.
Ah, so what's it called? Sorry, yeah.
MR
What's
Education,
it
I
called?
MR
Education.
Beautiful, thank
mixed
you.
reality. MR Education. Yes, I call that it. Yeah. Between all these areas, we called that area as a mixed reality. Mixed reality have to consist all virtual and the physical contents. But for the virtual reality, our idealistic model have to be completely virtual and purely cocooned all our reality to affect all our perceptions. So, the virtual reality, there are so many virtual reality definitions when we look at it, but the main definitions always emphasize the importance of the immersion. The immersion could be psychological and could be provided several different kind of components. I will mention what are they, but the main purpose, as I mentioned, is providing interactivity and making people's much more different from this environment, all surrounding their reality and indulging their all perceptions into the virtual world and virtual components. So, when we look at the virtual reality concepts, there are 5 I of virtual reality. If we call this an environment as a virtual reality, it has to be intensive, which means have to provide different kind of media components to stimulate all our perceptions. And also the other one is the interactivity. The human-computer interaction is the main, the fundamental of this topic actually. And the immersion is what we expect. Illustrative usually depends to the 3D objects, and it has to be intuitive. It is preferred because we have to interact all that virtual world using our exact body movements and motions. On the other hand, we cannot be surrounded by the virtual environment. So the main terms for the virtual reality is, first of all, the virtuality. Virtuality have to be pure and without any physical components. Even our conscious, in here, the virtuality also the supports by the presence concept. Presence is the most important thing, I think, because there is a really interesting experiments. Maybe you heard it before. There is a plastic arm experiment, and the people cannot see their physical arms. Instead of that, they are replacing a plastic arms in there, and their brain reacting as feeling real pain in that place. That indicates what is presence. So virtual environment have to manage our all mental perception like that. That is the main purpose. But there is another concept which is telepresence. Telepresence, in the telepresence, as a body, you have to be physically in that place, but you have to control the virtual components using the remote control systems. And the another important concept is virtual world. We usually call virtual worlds as a virtual reality, but it is not. Virtual reality is what I mentioned. Virtual world could exist without virtual reality or any environment system. We can think like a computer case. A computer could be executed without a computer case. You need only the main components as a hardware and the main board, that kind of things. So virtual world is a kind of combination of the virtual objects. So our main purpose, as I said, to catch up the philosophical immersion, which called as a total immersion either. This directly affects our presence feeling, and also it is supported by the high fidelity. High fidelity could be provided interactional fidelity, display fidelity, and the scenario fidelity. The good design using 3D models usually indicates the display fidelity, and the gesture control of the virtual environment as an intuitive way provides us as interactional reality, and the scenario reality is important but not always possible. I mean, the mechanism and systems could be explained using the scenario fidelity, but for intangible concepts you not always can catch this fidelity. And also the interactivity, again, I have to mention in this point. Until this part, is there any question that I can answer? Okay, I'm continuing. So
we just need to make sure that the person who's virtually breathing is on mute, please.
Okay, thank you. Virtual reality environments usually split two different main categories, which is immersive and immersive. Actually, as I mentioned, virtual reality has to be immersive, but achieving that immersion level is really hard. Because of that, the practitioners just offer the computer-based or vehicle-based kind of systems as a non-immersive environments that could be called as this virtual world or kind of technology enhanced learning environments. I can give you an example. For instance, the pilot training, or if you are a novice driver, you are usually using simulator cars before going to the real physical roads. These are all non-immersive areas. But the immersion of the virtual reality could be provided via sensory channels. Sensory channels requires the gesture control and physical body interaction, and the challenge-based immersion, which usually provides you via scenario fidelity, and the imaginative immersion, and this is directly related to the display reality. Actual immersion and the challenge-based immersion, they are together could be evaluated as a scenario part, and the symbolic narrative immersion usually clarified the intangible context, and the social immersion requires the collaborative learning environments or collaborative manipulation of the virtual content. When we look at the virtual reality technologies, as every kind of technology equipments, we can mainly split them as an inputs and outputs. The output systems of the virtual reality are HMDs, the head-mounted displays. We are using them, and there are several different kind of head-mounted displays. We always complaining these systems so expensive and we cannot integrate that into our educational environments, but there are so many opportunities that to facilitate this process. We always wish that to use tethered HMDs. They are physically connected to the physical computers, and it requires a cable systems and professional developers, etc. But as an alternative to educational usage, mobile phone integrated HMDs are released 3 years ago, and every smartphone could be integrated, not every, but the majority of them could be integrated into that kind of HMDs to to reach massive target audience. And there are standalone HMDs. They have a good quality, close to the tethered ones, and they have their own CPUs and the random access memories inside it to upload your own softwares into that, and really portative and accessible devices are they. And the input systems of the virtual reality environments, I said the gesture control. What is gesture control? We are interacting with using our hand movements or body movements in that environment. So we need tactile motors. Maybe we can use the gloves and different kind of vehicles, surgical robots, but usually that standalone and the tethered HMDs using additional controllers like wands and the buttons, that kind of things. And also today, in order to handle the creating 3D virtual environment, the laser scanners are released. They're a bit expensive, but they can duplicate that physical world after scanning to the virtual area, and you can create your own adventure into that. Also, as another option, the 360 videos and the interactive, that kind of videos. This is usually called as a virtual reality, but I have to mention that it is a panoramic area, not the really virtual area. But okay, at least there is a reality in here, and you can interact and provide some kind of feedback into your to integrate into your educational environment, and it's a good opportunity. So when we look at that screen, the left top one is the HTC Vive, and the controller usually provided with that wand systems, and also the bottom of that is the Oculus. That both devices are tethered HMDs and directly requires the connection to the personal computers. And the middle line, the cheapest solution is the top one, the cardboards. I am pretty sure that majority of you is familiar to that systems. And if you cannot buy these cardboards, you can easily create your own ones using some kind of papers. And the bottom of that is the Google Daydream. It is one of the high quality mobile based device, and not really expensive, and has its controllers as a wand system. And the right side are the standalone HMDs. The Oculus Go and the HTC Focus are the good examples for them. So you want to create your virtual environment and you don't know how your technology have to be selected. What is the important features? We know that we have to look at the CPU and the random access memory systems for the computers, and these systems for HMDs we have to be aware about the field of view. Field of view is so important because the human eyes can recognize the 210 degree usually, but that HMD's field of view usually changes between 40 degree to maximally 110 degree, which means you have to organize your virtual environments in a restricted area, not the 360 area. So it is really similar to the designing 2D learning material for the distance education system. You know, you have a really restricted area as a screen to share your students, and the other area offers you the content tree and the interaction areas. So in the virtual environment, again, that field of tree indicates where is the active place that you have to design into that area. And these sensors are really important because sensors indicate that are you using that virtual environment into the physical environment or outside environment? Did you use the motion tracking or the head movement tracking or the eye tracking? So it will indicate your requirements, your learning environment's necessities indicate that which sensor you need. And the latency is another important issue because we are always complaining about virtual reality systems causes to the cyber sickness. No, not virtual reality systems cause to the cyber sickness. Low latency of that hardware components, the cause of that. So another thing is the weight and screen size. They are important because we have to be ergonomic. On the other hand, students don't want to experience that systems for a long term. And the display means a resolution is again important feature. And the HMDs usually use LCD panels, but some of them using the OLED panels. So I said what is latencies.
What did you say the weight was?
Weight, the heaviness. There sometimes,
the display. Okay, right. Sure, sorry, I was looking for something more solid.
Sorry. The latency caused cyber sickness. I try to explain in that figure why it happens. Because, when you was a passenger at the ship, if you look at the direct little light of the television for a long time, your body moves, but your vision not synchronize and not calibrate in that point, and that makes you dizzy. It's the same thing. Your brain affects you like that. All about cognitive process actually. And what is degree of freedom? Degree of freedom could be component of HMDs and also the vent systems. 3 degree of freedom HMD is much more cheaper, and they only recognize and capture your head movements, as you can see in that point. And 6 degree of freedom systems capture all your body movements either. So, if you want to develop your own virtual reality environments, what do you have to use? You have to use, as a professional one, and as a novice one either, the Unity is really easy to use game engine. You need a game engines to combine all your different components into it and render and publish your final software. And you need 3D modeling softwares, Autodesk, Maya, these are the professional ones, but also the Blender is a free, and the SketchUp is released by the Google, and it is again a free area, and it's really easy to learn. YouTube consists several kind of tutorial videos to learn that. And for 360 video editing, you can use the Adobe Premiere, even Camtasia Studio, and if you have a bit information about game engine usage, you can integrate the Skybox plugin into the Unity, and you can create your own 360 environment into that. And also, there are low-cost opportunities to 360 video editing, like InstaVR. You are just uploading your recordings into that system, and it's like a drag and drop material development process. You can easily do that. What about, I said Unity is easy. Yes, it is really easy. There are 4 main components into that. One of is you have to know the structure. After you know the structure, everything are similar in the computer world, actually. At least in my opinion. There are parent and child systems. You know that parents always hug all the child, and their child under it. You have to arrange all the details as a hierarchically, and there's an inspector systems which helps to detail all the preferences of your each objects. Sorry, what is it? Okay. I'm not doing it.
People are accidentally clicking to control.
You just click on menu. Just click on menu at the top and go disable remote control.
Sure. Yeah. Okay. And there asset area. Asset area includes all your project folders, and you have to know how you have to manage your prefabs. That is all you have to know, except these information, the folder names indicates what you have to replace into where. You can easily understand it after watching some little tutorials, and also now I cannot control it too. Yeah, I did. And this is the interface of the Unreal Engine. I am not familiar to using Unreal Engine. I am always using Unity, but it is a bit more professional. If you want to develop yourself as a high fidelity display systems, you can use the Unreal Engine, and the animators or the video producers usually preferring that system. So, what are the benefits of the virtual reality? First of all, virtual reality helps to learn as a comprehensive process, assisting the communication and the decision making into the virtual environment. Also, the learning management systems provide us a reporting systems, and they require an extra module into it as a digital environment. Virtual reality environments can easily log every details to re-evaluate the students or the learning process again and again, and that provides you a constructive evaluation process. And also you can evaluate your learners' data using the scientific methods. Virtual reality's multi-stimulus structure, you know, the visual, audio, and the kinesthetic, all that components, broke the barriers on the individual differences for different kind of cognitive style learners. And as a benefit of this simulation, it provides you a safe environment to experience any kind of scenario as an iteratively again and again, and demonstration of the tangible concepts enhance your imagination potential. And also virtual reality environments provides situational inquiry, experiential discovery, and problem-based learning. What are the this is VR. I am so sorry about the heater. What are the limitations of the VR? First of all, we said that all about our perceptions. So each perceptions could be affected as a bad way because of the deficiency of hardware and software systems. For instance, sight as a sight, we can have eye fatigue, a headache, blurred vision, and also one of my participants' eyes are just tearing like a crazy. I don't understand why, but then we understand that she didn't replace the HMDs on the head as a good way. And the audio systems could, because of the hearing loss and the iterative movements into that environment, especially for the novice user of the virtual environments, really have a kind of 3D orientation problems into it, and that could be cause of the balance disturbance. And this is interesting, but sometimes people could live a phobia, but also virtual environments using to treatment of the phobias. And the other different kind of limitations we can meet. Until that point, I completed the what is VR part. Now I am continue to AR. Is there any question? No. Yeah.
It's good. Clear for me.
Okay. So, what is augmented reality? Augmented reality, as I mentioned at the Milgram's continuum, reality continuum part, it is augmentation of the physical world. So, it overlays the computer-generated informations onto the real world. It always requires a kind of combination of the physical and the virtual components, and we cannot say that virtual content always have to be a visual. It could be any kind of digital content, like a sound or that kind of things, a video. When we look at the AR systems, I will explain the marker and markerless based systems to understand these also indicate the types of AR as a main perspective. We said that AR systems requires both physical and the virtual environment. So that means we are dressing up the physical environments using virtual components. So this indicates that physical environment have to be recognized. How it will be recognized? Using, of course, the sensor and the tracking systems. Thanks to that, we can interact and develop all that physical reality. And there is another concept which is called as the inside out and outside in. This indicates inside out means the tracking systems integrated onto your body, and you are recognizing the out systems from inside. And the outside and in the opposite one, like a Kinect. There is an additional device onto me, and it is recognizing me. Outside in the environments, usually indoor augmented reality, because that device have to be fixed in a place, but inside out environments could be much more mobile and suitable for the outdoor usage. And there is another context called as a SLAM, a simultaneous localization mapping system. It is a visual search system. Actually, we can think that like a plate recognition. It is recognizing the physical objects position and the distance from the 0 point, your point, and create a new model on it. I will show the pictures, and it will be much more understandable after that.
Saying I've seen the terms augmented reality and augmented virtuality to refer to that inside out, outside in concept. Is that If I misuse, is that not an appropriate way to use those terms?
And inside out and outside in systems, all about the are you using your systems indoor environment or outdoor environment? Are you a mobile or are you a fixed? And tracking systems integrated your body or outside. But the augmented reality and the augmented virtuality concepts about the how much digital content are you using to enhance your physical or virtual environment? For augmented reality, the digital content using to enhance physical environment. But for the augmented virtuality, the physical contents are used to enhance virtual environments.
Yeah,
they're different.
But I reckon there's a similar, like there's a slight overlap in those
Ask you a question.
Yeah.
Sorry. Can I just ask you a question? So, are any of the schools using any of this technology at the moment?
Yes, of course. I am coming in there.
Oh, okay. I thought I just got a bit ahead. All right. Yeah, because I'm curious to know how they've been using it. Thank you.
You're welcome. Okay, as I said, when we look at the types of augmented reality, the marker-based systems are the most used ones because it's easy to create. You don't need any code or programming knowledge to create the marker-based applications, and they're usually developing using the QR code systems or the fiducial markers. And the geolocalization assisted, the location-based augmented reality applications again used thanks to the handheld device supports because it is really easy to access the massive target audience. But the other area that the markerless-based visual search, SLAM, and the visual recognition systems are a bit more professional. You need a coding systems, you need maybe artificial systems or the robotic integrations. So, we learned that what is the important point when we choose our technological equipments for the virtual environment, virtual reality. For augmented reality, we have to know about the tracking systems before we choose our hardware components. The important thing is, if you are designing a location-based augmented reality application, you need active tracking systems like a GPS. And if you are designing outdoor or indoor systems, but it requires to capture the body movements or the head movements of the user, so you need the mechanical tracking systems, which are usually called as the IMU systems, and they consist accelerometer, gyroscope, and the magnetometers, and usually the other tracking systems use the optical sensors. AR displays could be head-mount, the head-attached displays, handheld displays, and the spatial displays. What are these? When we look at this picture, we can see the differences between them. AR systems are usually using via handheld displays because we can use the mobile devices usually. And but if we want a more high quality augmentation of the physical world, we can use the retina or the head-mounted displays. But retina displays not really reflect the virtual objects to you. They're usually reflects indicators, like you can imagine the Google Glass. It can return you the information about your body heat and the movements, maybe males, but not really 3D concepts in there. And the spatial displays could be thing as a hologram technology. All these displays has their own advantages and disadvantages. So the main decision in that point, what is your learning environment, what kind of outcomes you need, you have to choose the correct equipment in accordance with this decision. augmented reality interfaces could be differentiated as a tangible AR interfaces, which are using as a marker-based one, the visual marker recognition or the QR code, that kind of things. And these tangible systems could be collaborative because every student could observe the same physical and the virtual content into the screen. But the other concept as a collaborative AR interfaces, this indicates different kind of collaboration. That collaboration is not a co-location collaboration, the remote ones. Just imagine that we are doing that meeting as feeling in the same place using all that display systems. And the hybrid AR interfaces requires a robotic and additional device integration, and the multimodal AR interfaces requires a physical body interaction with virtual objects. If we want to develop the augmented reality applications, we only need the SDKs for the AR SDKs. AR SDK is usually integrated into the game engine systems that I mentioned as a Unity or the Unreal Engine. So, like your augmented reality device components, your SDK components has to be compatible onto that. You have to, if you are using the marker-based, if you are developing a marker-based augmented reality applications, how many markers will you use? And are they markers will be movable or in the constant place, just stable? These all things will indicate which SDK is much more suitable to you. I won't explain all that tables, but there is the SDK types onto that and the features of that SDKs in here. And
so SDK is software development.
Software development kit.
So are there any ways of building interactive augmented reality environments without writing program code?
Yeah, using that SDKs, usually you're not using code. For instance, you can download the Vuforia or the Easy AR SDKs and you're plugged into your game engine and you're only drag and drop things after that.
Yeah. Oh, okay. Right. Yeah. I just assumed because the term SDK that it was actually writing code.
Yeah.
Saying not necessarily.
Okay, excellent. Augmented Reality SDKs provides you a cloud-based platform, and you can upload your pictures into that database, and that uploaded pictures indicates which are the physical components of you will track into your augmented reality applications. After that, you are adding the digital content into the area, and they directly merging that physical and the virtual components onto that.
So that actually requires an internet connection, a wireless connection wherever you're actually using it?
If you're not for the marker-based ones, once a time you're uploading that physical pictures into the place.
Oh, this is in the development.
Yeah, of course.
I was thinking cloud-based while you're actually using it. Yeah, okay.
So, benefits of augmented reality looks like more than virtual reality because augmented reality researchers are more than virtual reality. And the active participation is really essential, and it provides a collaborative learning environments and real-time interactions into the learning environments. Also, the digital contents is enhanced, and the instant feedback could be provided using augmented reality systems, and the researchers shows that the learning time of the students and the cognitive load of students are reduced after augmented reality application usage, and their motivation and the satisfaction factor increased, and their attention onto particular topic become a sustainable and increased, and the students' creativity and the memorization capability are increased, and augmented reality also, of course, provides a demonstration as strength on the tangible and the intangible concepts, and we know that thanks to the handheld devices, it is accessible and reduce the learning costs. In the literature, there is not actually particular limitations of the augmented reality applications because they didn't determine, as I understood, but they usually indicates that technical difficulties, it is really general term. What are they? It all depends what you will use, and the inexistence of required digital infrastructure. There are so many free assets you can find, download, even NASA's website, even the Unity's website. I am not agree on that, but I am completely agree about the teachers' resistance. They don't want to use the technologies because they have to effort more than their face-to-face education systems. As distance education, you have the extra material development process, which is really time-consuming. It is same for the augmented reality either. So let's look at the examples. Yeah, in here we can see the virtual reality usage for the chemistry education, and the lecturer can see the output of the student and can follow all that processes in his handheld display, and the children can understand that hard chemistry topics. It is really hard, at least it was for me. And not only understanding them, also they can merge the atomic structures to create new components and to see the interactions and observing all that processes. And also, when I was a young girl, we had a physics laboratory at this school, and we had a SCATL system, but it was always staying at the cross of that room, and I will never observe what are the SCATL systems and what are the muscles and the organs inside it. But in here, individually, students can have an opportunity to experience all that things. Also, the military systems using that virtual reality systems for the soldiers' education process, you can see a kind of bulky devices in here because he requires a backpack. That backpack includes a PC, the tethered things, and as a gun connection to polygon education in here, the shooting education, and also virtual reality technologies using for the strategy and that kind of soldier education systems either. As many kind of fields, new technologies released for the science and the military, of course. And in here you can see the astronaut education, the VR usage for the astronaut education via glove supported system. And the orbit controller education again in here for the astronauts. For the medicine, VR technologies using for the visualization process of the inside body, and also it is using for the reducing the anxiety level of the children during the surgical processes. In the engineering field, it's usually using for the assembly and the maintenance systems. As a collaboratively, engineers or the technicians can use, can work on the same system. Also, the architecture, the high cost thing and the huge projects, you can. You don't know the results of what will be happen after engineers that opinions, but you can simulate it into it before that. And also, of course, the game and entertainment area. one of the essential ones because people like fun things. The education, augmented reality usage and the education, we can use the marker-based augmented reality application in here. For that kind of systems, the developer have to prepare and design both physical and the virtual content, and after that markers recognized by the camera of the handheld device, the students can observe that all details. And also the letter word training and the mathematical equation training systems, which is one of my applications interface. And augmented reality also using to determine the specifications of the physical environment, high-risky environments, and working collaboratively onto that environment by soldiers. It is they're determining their battle war strategies using that systems like that. And also the augmented reality, collaborative augmented reality, we can see one of the example for the collaborative one in here. The astronauts are determining the Mars surface without being there as a collaboratively in the screen. And also again another usage for the machine. And augmented reality also using the medicine area during the surgery process to replace the extra devices into the patients. And before surgery, they are creating the bone models and determining which point have to be manipulated during the surgery. And before aesthetic surgery, they are creating the all face models using augmented reality either. And engineers and the maintenance systems using AR systems to work and inspect the systems collaboratively like that. Also the Mercedes using it. There are so many examples. Also the architecture, again, the inside, outside design systems. And the entertainment, everybody knows the Pokemon Go. Probably it has a 21 million user. It is augmented reality. Also, when we go to the supermarket, we can see the details of the products using some kind of augmented reality applications. Also, there are really different TV channels. They are explaining the sports strategies using augmented reality components. So, usually at the universities, what are they doing? They are trying to adapt these systems into their learning environments, but they're always, as I said, complain about the expensive and the unreachability of these systems. But especially the engineering, medical fields, engineering, medical, and architecture fields using these systems actively into their lecturing process, because especially the engineers and the architects using the AutoCAD programs into their lectures, and that programs consist several different kind of 3D components. So they are working on it together during their learning process. And in here we can see medical example, and in here we can see another one which is personal training into the university for the emergency situations. And another example in here, the professor using the VR application into the classroom for the chemistry education. And here is to see inside body using the HoloLens. It is HoloLens goggles. And the maintenance systems in here for the engineering restriction and the designing of the nanobiological systems in here. Also, the nurse is using for invasive learning processes the HMDs and the WAND controllers in here, and the robotic interaction of these systems again using. Also, augmented reality applications using for the medical educations, either, the medical faculties usually using the mannequins in their education systems, and that systems are really expensive and have sensors to reflect the result of the interaction of the students into the panels, but students don't have opportunity to observe what's going on inside. They can do it thanks to using augmented reality applications in there. And the neuroscience or the cognitive science students can understand what's going on into the brain, and the chemical experiments could be executed. And that kind of visualizations are using, it's only the marker-based one. They are using the real tablet computer to stick it in there, to attach it in there. Yeah, again, another chemical example. And also the magic books. Magic books are really popular because it's really easy to develop, and they are only recognizing that visual markers into that, and everybody, even every library using magic books in today. And some of the libraries at the China become QR code libraries, and they have libraries into their metro trailway using the QR code. They're downloading the PDFs in there, and they can easily read that. Yeah, that is all that I will mention today. Thanks for your attention.
That's fantastic. It really, it's just so important, I think, that we should be using these kinds of technologies, especially if they're being used out in the field. I don't know how extensively they're used out in industry and that. I mean, fairly extensively, particularly in engineering and all that, as you say. But where I see a great advantage of this is when we have so many distance learners to be able to engage in the same space, and that's one of the key kind of things. And so you might elaborate a little bit on that. I think you sort of said something about the Army was using that. They were sort of working from central control and then out in the field. And I'm just wondering also, sorry if everybody else wants to get a question, but also whether there's any real time. So I've worked with games before, sort of like serious games where you have the Internet of Things is streaming real-time data in, and you can adjust your strategies and that associated with the data. I'm just wondering whether that's actually in, I haven't seen it in an augmented space as yet, but I'm sure it would be.
As I know, these technologies all continue to developing, but as I know, there are really different remote augmented reality laboratories. The students of the engineering students can stunt the computer, and they can manipulate the equipments into the laboratory at the laboratory in their screen, and the physical laboratory into their university, controlling all the systems as a remotely, and offering every actions as a 3D as the next to the screen, and you can follow everything from using your computer system. So there is, but it has to be developed, and also we don't know any idea what are they developing, because not every application developing for the academic reasons. Some of them are hiding under the companies and that kind of things, and we cannot observe the usage result of that applications, but there is, and it is possible technically, of course.
I'm just thinking that especially in like emergency services and kind of like things like bushfire kind of things. If you had real time data feeding in, that's feeding back to what you've actually done, and then feeds in other data, that would be a really rich learning experience.
Yes, they are doing it, and there is a patent. It has been gained the last year. one of the interaction of the user for the augmented digital content could be observe the other one, and the other one could be manipulate the same thing, and they can observe it together. That patent could be, it was last year, but I don't know how they applied it.
Yeah, okay.
So I wonder if Zainab maybe give the remote people a chance to ask some
Sure.
questions, because they'll get cut out in 3 minutes. Yeah.
Hey, do you have any questions?
Victoria, you're on mute.
This Karen here, and unfortunately I've lost my video, but I just wanted to form in the link connection. Just wanted to say thank you very much for putting the presentation together. I can see you have a lot of expertise in this area, and I'm sure that lots of people will have questions. So thank you again.
Thank you. Thank you very much.
One thing Zainab didn't talk about was the work that she's doing while she's at CSU on her postdoc, and I think maybe a seminar later on in the year where you report on some of the different. She's got a few collaborations going with researchers in creative industries and also science.
Yeah,
so
sure.
there might be.
I will be
would be
appreciated,
really
of
valuable
course.
to kind of give an update on some of the work that you're doing in that space.
Because we really need to look at the kind of learning design that we could develop, using that, and the different kind of pedagogical approaches that
Yes, of course. I know.
And that's really, I mean, you've got really strong technical knowledge about how to do this, but your research is really the educational applications.
Yes,
which
of
has been
course.
a lot about the kind of learning design issues around it. And so on.
I am an educational technologist, but I have a special interest for the technology and the computer system.